Welcome to e-learning. This time the subject is about temperature gradients, and please note this one is building upon the one with U values. As with U value, we have the calendar to help us. It is so that temperature gradients builds upon U values, so if you have difficulties doing U values, look at the lessons in e-learning concerning U values. That also means that first you must find resistance, you must find sum of resistance, U value and heat transmission before we come to do what we have to do today, and that is to find the temperature in the intermediate layers. Please note the way theta is indexed. We are going from internal layer to first layer. To do that, we need heat transmission loss, we need resistance internal, and we need temperature internal. Let's look at the problem we have to do today about temperature gradients. And as you can see, the problem we have to do this time is building upon the one you did last time with U values. So we still have a single glazed window, and the thickness of the glass is still 2 mm. I've been working a bit beforehand to write up the things we have to use to solve the problem. And the things we're looking for today is the temperature in the first intermediate layer. And the first intermediate layer is called layer I,1. And in this case, it is where air meets glass. We also have to find the value of the layer E,1. And that is the layer where glass meets air. And we also do a calculation for external temperature, even though we know the value. Below the sketch you can see I have written up some values that we found previously in the U value calculation, and that is resistance of layer 1 and heat transmission loss. Furthermore, I have written up the equation, and remember we always write up the equation to use and then we fill in with values. Filling in with values, I have to take 20 for the internal temperature. So it's 20 minus internal resistance, and internal resistance is 0.13, and then 0.13 must be times with heat transmission, which was 185.6, and that is the same as minus 4.1 degrees Celsius. Now I have to write up the next equation to use, and I have to find the temperature in the next intermediate layer, the layer called E,1. So what I have to do is I have to write up the temperature in the layer I just found, and that was temperature in the layer called I,1. And then I must subtract it from the resistance in layer 1, and then I times it with heat transmission loss. If you look a little bit closer on the equations, you can see it's like they are rotated, and we always use the one we just found to find the one we're looking for, and we are moving inside the construction before we use internal resistance, but now we have moved a step in, and that's why it's resistance of layer 1. Heat transmission comes always with you. So what I do now is I fill in with the values, and the value for the temperature just found was minus 4.1, and that must be subtracted from the resistance in layer 1, which is minus 3.13 times 10 to the power of minus 3. And resistance of layer 1 must be times with heat transmission, and that is 185.6. So the temperature for layer E,1 is equal to minus 4.7 degrees Celsius. So the only thing I miss now is I miss to do the check-in and see if I get minus 12 for external temperature. Now I write up the equation for finding external temperature, and that is the temperature just found, which is temperature in layer E,1 minus external resistance times heat transmission loss. So I write it up and I get, when I fill in the values, which I think you should do, I get minus 12.1 degrees Celsius. And if I have been more aware of keeping all my decimals in my calculator, I would have hit point blank. Try and see what you get.